Good evening, my dear students. In the previous discussion, we have discussed about type 3 when the function f of x is of the form of x or x raised to n, that is polynomial in x. And I have asked you to solve the problems in your home by calling them as assignment questions as displayed above. These three questions we have to solve. Now, further moving for mixed type problems. Mixed type means it is a combination of type 1, type 2, type 3 together. Solve dq plus 1 into y is equals to cos pi by 2 minus x plus e raised to x. So here this is cos, this is e raised to x. So here I can call this is type of 1, this is type of 2. Cos hyperbolic 2 minus cos pi by 2 minus x is type 2 and e raised to x is type 1. So we call it as mixed type problems. Before going to find yp, let me find out complementary function yc. For that, I am considering dq plus 1 into y equals to 0. That means the given linear differential equation is considered as homogeneous. We write auxiliary equation m cube plus 1 equal to 0. This is cubic 1. To solve cubic equation, which can be solved by factorization, we have to check whether it is can be solved by factorization. By looking towards the term m cube plus 1 equal to 0, it's not possible to solve this by factorization. So for that, I am using synthetic division method. To apply synthetic division method, first we should write down a root of the equation which satisfying the RHS. By substituting the suitable value of m, I should get that equation must be equal to 0. Here by inspection method, we found m equals to minus 1. When you substitute m equals to minus 1, I am getting minus 1 whole cube plus 1. Minus 1 whole cube is minus 1 plus 1 is equals to 0. So that means by substituting m equals to minus 1, it's satisfying RHS. So I can easily write down this equals to minus 1. That is m equals to minus 1, which is obtained by inspection method. The other two roots are obtained by using synthetic division method. So in this method, this is the common root. I'm selecting minus 1 is the first root. Then writing coefficients of m cube, m square, m and constant. But here coefficient of m cube is 1. There is no term containing m square, which is 0. Coefficient of m is not there, which is 0. But constant is 1. So I have written order wise cube square 1 constant. So 1 0 0 1. It's a first rule that 1 is should be added with 0. So 1 plus 0 equals to 1. This 1 and this minus 1. This 1 and this minus 1 are multiplied together. So as a product we got minus 1 and 0 minus 1 will be minus 1. Again this minus 1 is multiplied. Product is 1. So 0 plus 1 is 1 again. This 1 and this minus 1 is multiplied. We got minus 1. Minus 1 plus 1 will be 0. It's very simple. Don't get confused. Minus 1 into 1 will be minus 1. This and this will be minus 1. So we got 0 minus 1 as minus 1 after adding. This minus 1 is multiplied. We got plus 1. This minus 1 and this minus 1 produces 1. So 0 plus 1 will be 1. Again This 1 and this minus 1 is multiplied, we got minus 1, 1 minus 1 will be 0. So we got plus 1 minus 1, 1. So here we are using synthetic division method, which reduces the power of m square, m cube to m square. So here I have written m square, coefficient of m square is 1, coefficient of m is minus 1, that's why I have written minus m, constant is plus 1, we got equal to 0. So we got m square minus m plus 1 equal to 0, which is quadratic in nature. Thus quadratic equation can be solved by using factorization, but this quadratic equation is not solved by factorization. If it is not solved by factorization, we know to use Sridhar rule, that is minus b plus r minus square root of b square minus 4ac divided by 2a. Here a equals to 1, coefficient of m square, b equals to minus 1, coefficient of m, c equals to 1. A equals to 1, coefficient of m square, b equals to minus 1, coefficient of m, c equals to 1, coefficient of constant. So using these ABC value in the Sridhar rule, m equals to minus b, that minus of minus, because b is minus 1, minus into minus plus 1, square root of b square is minus 1 square is 1, minus 4ac, a is 1, c is 1, we got minus 4 divided by 2. So we got 1 plus r minus square root of 3 by 2. It's like this, 1 plus r minus square root of 3, that to minus 3 divided by 2. But this can be solved like this. So I'm writing 1 as it is, then plus r minus square root of minus 3, I'm writing I square into 3, because I square is minus 1. I square into 3 divided by 2. Later, I'm taking that I square outside, that becomes I. Root 3 remains as it is, divided by 2. So finally, after taking I square outside, I got 1 plus r minus I root 3 by 2. So here we got 3 roots, m equals to minus 1 first root, and m equals to 1 plus r minus I root 3 by 2. This root is real and this root is complex. So we are writing yc equals to c1 e raised to minus x for real, and for imaginary e raised to x by 2, c2 cos root 3 by 2 into x, c3 sin root 3 by 2 into x. We got complementary function. Now proceeding for yp, yp equals to cos of pi by 2 minus x plus e raised to x divided by dq plus 1, because our given f of x is a combination of type 2 and type 1. And we already know standard result, cos of, we know the result, cos of pi by 2 minus theta, cos of pi by 2 minus theta is always sin theta, is always sin theta. So with that result, I am writing cos of pi by 2 minus x as sin x, and e raised to x remains as it is. So here, for understanding purpose, I have written type 2 and type 1. For simplification purpose, I have selected yp equals to p1 plus p2. Okay. Further, I'm moving towards next slide. So here, p1 equals to sin x divided by dq plus 1, sin x as it is. In denominator, I'm making adjustment. D cube can be written as d into d square plus 1. I'm making this because I know in type 2, I have to replace d square by minus of a square. So I'm writing sin x divided by d as it is. D square I have replaced as minus of a square, that is minus 1 square. This one I have obtained from this sin x, it is sin ax. A is 1. Coefficient of x is 1. So I have selected a equals to 1. So I am written d into minus 1 square plus 1. D into minus 1 square will be minus d plus 1. So I have written sin x divided by 1 minus d. So P1 equal to, using the process of rationalization, multiply and dividing by conjugate of 1 minus d. So I got P1 equals to 1 plus d into sin x divided by 1 minus d into 1 plus d. So simplification, 1 into sin x is sin x. I got differentiation of sin x is cos x. Numerator, denominator, it is of the form a minus b into a plus b. And we have a result, a minus b into a plus b can be written as a square minus b square. So 1 square I have written 1 minus d square. Then again replacing d square by minus a square. So I got minus 1. So here minus into minus plus, minus 1 square is minus 1. Outside minus, minus into minus plus. So we got sin x plus cos x divided by 2. So this is P1. Now P2. P2 is e raised to x by dq plus 1. It's very simple. Coefficient of x is 1. E raised to ax, a is 1. So we got e raised to x, replacing d by a. I got 1 cube plus 1. 1 cube will be 1. So we got final result e raised to x by 2. So we got P1 as sin x plus cos x by 2, P2 as e raised to x by 2. Adding these two, we got yp as sin x plus cos x by 2 plus e raised to x by 2. This is our yp. And yc we have obtained earlier. Adding yc and yp, we will get general solution as here plus this yp. So this is a discussion of a mixed type of problems. So as for understanding purpose, I have given assignment questions for a people like 4, 5, 6, 7. Here I have given hint for example number 8. Cos of hyperbolic 2x minus 1 can be written as e raised to 2x minus 1 plus e raised to minus 2x divided by 1, because cos hyperbolic x is e raised to x plus e raised to minus x by 2. Similarly, 3 raised to x can be written as e raised to log 3 raised to x, which is e raised to log of 3 into x. 2 raised to minus x, e raised to log 2 raised x raised to minus 1. That again minus of log 2 into x. So here you can use a as minus log 2, a as log 3. With this, I hope you understood type 3 and next type of problems. Thank you very much.